Welcome to a reading of Architectural Rendering. This portion is called Sketching Applications, and it's from Technical Drawing. Some students have not had the hand drafting course, and so I am including this because there are special hints, tips, and techniques that can be learned from that class that apply to this class as well. So let's begin. Sketching, also called freehand drawing. It's drawing made without drafting equipment. And the drafting equipment, of course, would be the T-square or any kind of parallel bar and a right angle. Only paper, pencil, and eraser are needed. Very simple ingredients, very mobile. Maybe you can take it out and make quick drawings in the field. It's a fast visual communication, and it's an asset for communicating technical concepts to others. How often have you drawn a picture of your pipe drain or your car slots or something that you needed to just draw a quick picture to let someone else know what is needed? You can take this to computer-aided drafting, and this typically prepares the sketch onto graph paper, and when you take it to the computer, it's actually establishing coordinates and it's organizing the drawing before beginning. You can record stages of progress on the computer by saving each time you begin, and you can see where you came from. Sketching tools. Our favorite is pencils. I recommended that ebony pencil for drawing shading and tones. It's a thicker black lead pencil. But technical drawers also use a very hard lead pencil, and this is a number 2, which is your typical test for the SAT tests or any kind of test will have a number 2 pencil. But your mechanical pencil can load different leads, and you can purchase leads in H, F, or HB lead. There's an automatic 0.7 millimeter or 9 millimeter pencil. Now, my preference is 0.5 because it's a bigger pencil. These 0.7 and 0.9 are really small, and it's okay for drawing, but when you try to reproduce it, when you go make a copy of it, it will drop off. So I like the darker leads. Stick to number 2. It's the cheapest pencil you can find, and you don't have to do much to alter it. This class likes a slightly rounded, not sharp point. So if you're doing true hand drafting, you would prefer the sharp point. And almost any type of paper works. So this is called newsprint, being the lowest and cheapest, something you might find at Walmart for kids. And then there's also our sketchbook, which is more higher grade. First techniques is really to master the line. You're going to master the line. We want to make sure that we can draft a line straight without the use of a ruler. And one way of doing this is to practice this little technique. Draw a line from A to B and try to do it with your hand only and try to aim. And it always helps to aim towards the B. And on the second little one, they're showing that you can do this. You can do a stutter step, right? There's a little break in there, and then you can make a complete line. This comes down to the topic of strokes, like how you train your hand to go in a very straight manner. Short 2 to 3 inch strokes really helps the line to work, helps the hand to learn this technique, and so does dot to dot. Strokes it's actually used a lot in painting, in lettering, and it actually helps you to train your hand. Let's move on to sketching circular lines. Another the biggies, right? The big thing here is, can you make a perfect circle, not or near perfect, humanly possible? There's a couple of ways of doing this. You see the circle here given its geometry. If we can do the radius, half of that, and then double it, we can get that perfect circumference. Some of the nomenclatures, the diameter and the center are used. Let's talk about the Trammell method. the hand compass method, and the nail and string method, mostly used for outdoors. This would be the trammel method, which is if you take a straight line, in this case a piece of paper, you label A and B, and to get the circle you divide half of that distance of the radius or whatever that line is going to be, hold down the center where B is, and then rotate that paper with the lead, of course, because you need a scribing device, and that is the trammel method. And woodworkers use this a lot, carpenters. The next one is to create a hand compass method. So you're actually taking your hand to make a simple compass, and I don't know if this is an entirely helpful view, but give it a try, and you might have tried this. I usually lay down my pinky and then I hold the pencil like this, and then you can see the person is going to turn the paper until they come full circumference, and that will leave a full circle. And they didn't discuss the compass, but I will bring that. The compass is a mechanical instrument. You need to see, it's a picture you see a lot of. I'll include a little video on this page to show its use. Very important. Next topic is measurement lines and proportions. All lines are related in sketches. Size and direction. Sketches should be proportional. Actual size depends on paper and sketch size, and pencils may be used as a ruler for measurement. Tripping over myself. Line 1, line 2, there's a measurement line, and then we can construct, we can take our lines that are simple lines, add measurements to them, and then with that we can create actual measurements leading up to the building of something. In this case it's a table. I assume that we're looking at it in a top-down view. The block technique helps determine shapes and proportions. Say you want to draw elevation of a house, but sometimes you start here, you may not get the same result. But if you draw a box, everything has to fit in there, and so when you get to the top of it, that has to be where the building is terminating. This is the elevation to be sketched. This rectangle is important to establish as an overall width and height of view. Use construction lines. Construction lines are going to be very important when we start creating perspective. And here it's being done for you. They're using construction lines, so I'm going to come down here. They're actually building coordinates, simple coordinates. If you know your Cartesian coordinate system, that's what they're doing. Here's a better picture of it. You can just draw the object if you're talented, and you can just capture its shapes. But for the rest of us, we need a bounding box or we need a grid. And a grid is cool because you can take a complicated shape like this kidney and just break it up into little parts so that you can say, I'm coming around here and I've completed the whole part. It's a very good technique. Multi-view sketches are used in projection. There's multi-view projection and elevation views. Multi-view projection, views of an object as projected upon two or more planes in orthographic projection. That's a mouthful, orthographic. And elevation are simple two-dimensional views established by a line of sight perpendicular to the surface object, meaning you're going to be very flat. Pictures tell a lot more. Sketch front view. Multi-view sketching technique is the two-dimensional views established by a line of sight perpendicular to the object surface. So in hand drafting, we're going to do a lot of this, but it's an important concept that to recreate something, you have to make it into informative drawing. So front, top, and right side can be translated into 3 dimensions. So we'd probably be drawing the 3 dimensions and not thinking like this, but when we want to rebuild this, we would lay it out like this so we can accurately build it. provide three-dimensional pictorial representation of an object. These are isometric sketches. They look a lot like perspectives, and I have to go a little bit faster to meet my deadline, but let's say this is a 30-degree line, and it creates something like this. An isometric is a simple perspective. It's not a true perspective because it doesn't end in a vanishing point, but it puts things in a box, and it looks three-dimensional. Isometric circles and arcs. Circles don't look like arcs. If you flip a coin, it has this image as it's falling down, but it's not a perfect circle. But you can translate these and attach these circles can fit 3 equals right plane, top, and left plane. So when you take my computer class, we talk about X, Y, and Z axis. You can sketch isometric circles. You can now sketch a box to help you sketch an object. That's one of the key ingredients. An orthographic projection just means we're going to take it flat. And whenever we look at a building, we're going to look at it flatly. This is not really part of sketching. I'm just bringing you up to date. And multi-view isn't really part of hand sketching, but just know that every object has 6 sides: top, bottom, front, right, left. And so you can unfold these like think of a pair of dice. If you open up the dice, you would have something that lays out like this. Taking flat things and making them three-dimensional is really big for us. That's what we do all day. We translate this 3 dimensions into this when you take the drafting course. Okay, and then this is just you're welcome to read this part if you like. Doesn't really pertain to us, but just know that there's a foreshortened thing that happens, which means we don't get that accurate measurement because we're looking at it and it's at an angle. That happens in drawing. And this concludes this portion, which kind of brings you up to date on what technical drawers use. And we're going to try to take what we need from this particular set, from this document, and translate it into our architectural rendering.